Hi, this is fifth part of the video for the correlation analysis. So far we have computed y minus y bar whole square for the first value. You can do it for the same for all of the values. Let's suppose I'm doing for this seventh number value. So y minus y bar has been already calculated in this column. Just this, look at this value 63.6 multiplied by 63.6 and you will get y minus y bar whole square for this value. I have computed all those values in the next slide, and so far we have computed all those columns. You can see it here, x minus x bar this column, y minus y bar there, x minus x bar whole square this one, and y minus y bar whole square this time. And here you can see it is the summation of the product of these two values, these two columns, x minus x bar and y minus y bar. So these two columns have been multiplied there and we got this answer. Now we need the sum of this column, so I will take the summation of all of the values, that is 11303.1 plus then minus 290.7 then plus 3 dots then plus sign, then the last value, that is 44.1. and you can use this is the standard way for writing in your assignments as well as in your exams and quizzes. So we will get the answer, and I have calculated this in the next slide. This is equal to 17,223. Likewise, I have taken the sum for this column and it comes out to be 32,600.5, and y minus y bar whole square is equal to 15,728.4. For example, if you want to take the sum of this column, so you will write summation y minus y bar whole square, and this will be equal to 985.96 plus 129.96, then the plus symbol, then insert the 3 dots, then plus sign, and in the end write 1.96 and you will get this value. However, in the calculator, please insert all those values. If you are doing the Excel, then this is the command is equal to sum, sum, insert the bracket, select this whole column in the Excel, there close the bracket and then press the enter sign. You will get this answer 15,728.4. So if we now look at this formula, we have already computed over numerator and it comes out to be 17,223. Now we have to work on our denominator, x minus x bar whole square multiply by summation of y minus y bar whole square. So these two values has been computed there and it comes out to be, before taking the square root, this we got this value, and upon taking the square root we got 22,644. So our rho, or you can say our correlation coefficient, or that is represented by r, upon dividing these two values we got 0.760597. If you want to do in the Excel, so you will get this answer you will get the result in this form, and the same correlation we got from this hectic and lengthy calculation, and you can do in the Excel in a second. So after getting the result, you will have to look at this table. These tables are available in most of the research paper as well. You can easily get it on the Google. So our correlation was 0.760, and this correlation lies in this range from 0.6 to 0.79. Please do not get confused from this minus and plus symbol. It means that the range is from plus 0.6 to plus 0.79 if you have a positive correlation, and it means that if we have got talk about a negative correlation, then it will be from minus 6 to minus 0.79. So these values have been given for both of positive correlation and negative correlation. However, our correlation value is found to be positive, so it lies in this range, and we can say that our correlation coefficient is moderately high correlation. So we can say that there is a moderately high correlation between the house area and the house price. The technical way of interpreting the correlation coefficient is the Pearson correlation coefficient of R is equal to 0.760 indicates a moderate high correlation between the house area and the house price. This equates to an R square coefficient of determination of 0.577. It means that explaining 57.7% of the variation of the variance between house area and the house price. In non-technical words and in the layman language, we can say that house price depend upon a lot of the factors. In all of those factors, the house area is such a factor that explains 57.7% of the variation in the price of the house depends upon this house area. Maybe it depends upon the look of the house, location of the house, like too many factors. This one factor is contributing 57.7%. Using an alpha value of 0.05, we can get such values of the probability with the help of either programmable calculators or Excel or Minitab, SPSS, any software. The result indicate a p-value of 0.000 because this question I also solved in the Minitab, and this series contain all those videos in the Minitab, SPSS, and the Excel along with the report writing in which a detailed graphs also have been made. Therefore, when we have the p-value less than 0.05, this 0.05 we can call it significant level or cutoff value. We got our p-value 0.000 less than 0.05. So this is the criteria that when our p-value is less than 0.05, we reject the null hypothesis. This criteria has been satisfied in our case, so we rejected the null hypothesis and the alternate hypothesis accepted. It means that there is a statistically significant relationship between the house area and the house price. That was all about the series of the correlation analysis. Thanks for watching this whole series. Bye.